handling is an important topic. As developers, we need to be aware of it and make use of it. So any code that is likely to have some errors while executing, we should not ignore such errors or such exceptions. Instead, we should use try and catch block to handle exceptions that might be thrown by certain piece of code. And I'll give you examples shortly. In Java, there are so many exceptions. We will see some of them. And we will also learn how to throw an exception, including throwing a custom exception. So for the try, catch, and finally, we already seen the basics of this. So in some actions that our program might be doing, such actions can throw some exceptions. Here are examples of exceptions that can be thrown while running a program. So if our program is trying to read a file, an exception could happen if the file is not there. Somebody deleted it, so we try to read the file is not there, an exception will be thrown. If a program is trying to read from an array and suddenly it is trying to access an element that is outside the acceptable range. You know, for an array, the acceptable range is 0 to size -1. If you try to access an element outside that range, an exception will be thrown. If you are doing some network programming and you are trying to receive a file through the network, maybe the network could fail. We know this. Sometimes our Wi-Fi does not work or network does not work, then you will get an exception. So if you don't do anything about this exception and we just ignore them, your program will simply terminate. And this is not very good news, and users will not be so happy about it. So when you're trying to do some type of actions such as these ones are likely to have some errors associated with them. So you better handle such errors, instead of ignoring them. Here is an example that we already see. So for example, what I have here, I have a set time method. In this set time, I have some validation rules that I'm putting in here. So for example, the hour must be between 0 and 24, the minute and second must be between 0 and 60. If this validation rule fails, then we throw an exception. In this case, I'm throwing a new instance of illegal argument exception. Means that the arguments passed to this method are invalid. And then the caller of this set time, it knows that something might go wrong when I set the time. So instead of just calling this by itself, we put it inside the try and catch. We give it a try. If something goes wrong, then we will catch it and do something about it. In this case, I'm just displaying the message. So a more realistic scenario, maybe you came across it before. You're trying to use some kind of program, and that program needs some file, maybe some initialization file. And suddenly that program does not find the file. So sometimes the program will ask you, can you please help me locate this particular file that I need for the program to execute correctly. So that's an example of exception handling. So what we have here is, if some exception happens, as developers, we can throw an exception. The way we do it, we use the throw statement followed by an instance of an exception. An instance is like creating an object. In this scenario, I created an object of type illegal argument exception. So I create an object and throw it to the caller. And then the caller needs to catch it by putting the method call inside try and to be able to catch the exception that will be thrown. There are so many exceptions that come with Java. These are some common ones. Most likely you have came across some of them, especially this one. I'm sure you have seen this before. So if you create an object that you did not instantiate, you just declared it, but you never created the object itself. And then you try to go to the object and access its methods, then you get this null pointer exception because the object is not created and you are trying to access it. Whenever you try to read and write, I'm sure you have seen this. You get an I/O exception if the file is missing, or the file, or let's say you're trying to write to the disk and the disk is full, as an example. You get an I/O exception. So the idea here of the try and catch, any code that is likely to throw some exceptions at you, you should put it inside the try. Then the potential exceptions that might be thrown, you put them in the catch and you handle them. And the finally, this is the block we haven't seen before. The finally is usually used for some kind of cleanup. So I think the best, let me just give you a small example here. So what I have here, we've seen this example before of using the print writer. So the print writer, if I want to create, or let me show you. If I want to create a print writer, can you see here? Java compiler is complaining. Unhandled exception of type file not found. So when I try to create an instance of print writer, I must put it in a try. Otherwise, the program cannot compile. So what I can do here, I can basically take this instantiation and put it inside the try block. And here I'll just say null. Okay. And then in the finally block, I check if the print writer has been created successfully, then I will go ahead and close it. So the finally block is used for cleanup, such as closing the files. It's a good idea to close files once you are done with either reading from them or writing to them. I'm sure some of you have came across a situation when you try to delete a file and the system says to you the file is in use. That is most likely because maybe some lazy developer, they just keep on opening files, reading from them, and they never close them. So the program in the background is still holding them. So it's always a good idea to, when you deal with files, to go ahead and close the file. And the best place to put it in this is to put it in this finally block. And the finally block will always be executed, whether there is an exception or there is no exception. When the program finishes, when the try block or the catch block finishes, it will jump to the finally. So the way it works, if anything happens in this area of the try, this try will, the code in try will terminate immediately, and it will come to the exception handler, and run the exception handler. Once the exception handler is finished, it will go to the finally block. So the finally block is always executed. Whether there is an exception or there is no exception, finally it's always executed. And it's usually used for cleanup, such as closing files, closing database connection, later we will see in future courses, closing network connection, all those resources, all those things you have asked the operating system to give you to use in your program, you should close them. You should clean them up. Because these resources are shared. Maybe you finish with this file, you should close it because other programs might open it for reading or writing. For example, if you open a file for reading, other programs cannot write to it or cannot delete it. So you better close. And the best place to do cleanup is in the file. So that is the idea. Okay. Yes, please. That's why I checked in here. If we manage to successfully create an instance of out, then I close it. Of course, if it's null, if it's null and I try to close it, what will happen? It will throw an exception. And then the finally will be causing program termination. So you need to be very careful here. I check before I act, because there is a risk that the creating instance of printer writer will fail, and if it fails, the out will be null. So before I close it, I check whether it's null or not. And if it was null, we don't need to close it. Null, what does null mean? It's not even created. How can you close it? Okay. All right. Moving on. So that's the idea of try and finally. This diagram is nice diagram, but it's incomplete. I will fix it later on. So what happens? This is how the try and catch work. So you put some code in here in the try. If something goes wrong in the try will terminate immediately. It will terminate, and then one of this lucky catch will be executed. I will explain how we select which lucky catch will take care of the exception. But in reality, when the try is finished successfully, or when the catch finished successfully, before we go to the statement after the try block, if there is a finally block, we will execute it first. So as I explained, the finally block is always executed, regardless of there is an exception or no exception. So this is what I just explained. So if an exception happens in the try block terminates immediately, and we move to the catch block. And when the catch block finishes, it will move to the finally block. And when the finally block is finished, we will move to the statement after the try and catch block. By the way, if there is an exception in the try block, we can never go back to the try block. That's it. We terminate, we exit, and we go to the catch. We will not go back to the catch block. So just be aware of this. So the catch block, once there is an exception, that's it. We lost the opportunity to complete the try block. The try block is terminated fully, and we cannot return back to it. Okay. All right, so the finally block, as I explained, is usually used for cleanup, such as closing files and so on. All right. Now, when we have multiple exceptions, or multiple catch blocks, how the system decides which block will be executed? Because only one of the catch block will be executed, not all of them. So if I have multiple, how can we decide which catch will be executed? What is the idea here?
I think it's going to compare the exception found with the types of exceptions that we catch.
Yes, thank you. So the exception, at the end of the day, the exception that will be thrown, at the end of the day, it is an object, yes? And we know an object is always associated with a class. So an object is an instance of a class. So based on the exception that is thrown, based on the class of the exception that is thrown, if the class of the exception is file not found, this is the lucky catch that will execute, and the rest will be ignored. If the exception thrown in the try block is an IO exception, then this one will be executed. If it is something else, for example, it's division by zero exception, or if it is illegal argument exception, it's not handled in here. So it will be given to the caller. So let me explain this. This is very important to understand. So typically, in our program, we might have a main method. That's the entry point to start the execution of the program. So the main method might call another method, such as, let's say, compute. So the main will call this one. And the compute might call another one. Let's say a read file, for example. So if an exception happens here in the read file method, if we handle it in here, if we handle it at this level, that's it. They don't need to handle it. If we manage to handle it in this method, the read file, the error will be handled or the exception will be handled and everything will be okay. If we don't handle it in read file, what happened to the exception? It will be thrown and received by the caller, which is the compute method. If the compute method handles it, it's fine, we can resume execution as normal. If it doesn't handle it, if the exception is not handled in here, it is thrown to the main. Now the main, if it doesn't have an exception handler, it will be thrown to the virtual machine, to the Java runtime, Java program running, the Java virtual machine running our program. And at that stage, the program will be fully terminated, and the Java runtime will display an error and terminate our program. So what I mean by this, and if like we have here a hierarchy of calls, one method calls the other one method calls the other one. The last called function, if there is an exception in there, if it's not handled in that function, the exception will be given to the caller. If the caller does not handle it, the exception will be given to the caller of the caller, and so on. Until, if there is no handler, this will cause the program termination. So what I mean in this scenario, in this particular block, if an exception is thrown, we will match the class, the exception class with one of these exceptions. If one of them match, then we will go ahead and execute this. If there is an exception that is not file not found and not IO exception, then the exception will not be handled and it will be given to the caller to handle. If the caller does not handle it, it will go all the way to the main. If the main does not handle it, it will go to the runtime, the Java runtime, but we have no choice but to terminate your program because there was an exception that was not handled. Okay, now remember, exceptions, they inherit from each other. The root, typically the root exception class is called exception. And then in this scenario, we have an IO exception that extends exception, and we have file not found exception that extend IO exception. Yeah. Now, this is important to keep in mind. The order is very, very important. So if I change the order here, let me show you. If I change the order, just to reduce this. And suppose I'm trying to read the file here, and the file does not exist. And this one, this block here, throws a file not found exception. So which catch will catch it? So remember, yes, it will be caught by this one. Remember that this relationship, what did we say about this inheritance relationship? What's another name for it? Thank you. It is an is-a relationship. This one is a relationship. So file not found exception is an IO exception. So this lucky catch will also catch file not found exception. Why it will catch the file not found exception? Because it is a superclass of file not found exception. So this will miss out. So that is so the order in which you put the catch block is very important. And the guideline here is to go from specific to general. If you put the general ones first, then the specific exception will miss the opportunity to handle the exception. So even if I do, for example, in here, if I do something like exception, this will handle all types of exceptions. And this will never be will never have the opportunity to run. Because the first exception that match is the one that will be executed. When I say match, it does not need to be matching that particular exception. It could be matching a superclass of that exception. So because all of them inherited from exception, this will even if here, if I have a file not found exception, this catch block will match the file not found exception, because file not found exception is an exception. An exception class is a superclass of file not found. So the idea here, what we should do, we always put the specific exceptions first, then followed it by the general exceptions. Otherwise, if we put the general exception first, then it will kind of not allow the specific ones to handle the exception. This is an important point, please keep it in mind. Okay, now in the catch block, if I find myself that there are multiple exceptions and I am handling them in the same way, so one way to do better coding is to basically here put this pipe to say, if there is instantiation exception or no such method exception or invocation target exception, all of those, I want you to handle them this way, the same way. So I can have kind of an or. This one here, it's either this exception or this exception or this exception. I want you to handle them all in the same way. So this allows us to avoid repeating this code multiple times. I could, of course, have one catch for this, one catch for this, one catch for this. That's one way of doing it. If I do it that way, then this code will be repeated. But in here, I'm handling multiple types of exception using one catch block. And in this scenario, I'm separating them by the pipe, indicating any of those. This is the code to handle the exception.
Is it not exception throwing?
No, this is my own function, some function that is. This is very common in practice when an exception happens. Developers, they tend to write it to file first, then maybe throw it again. The reason why we write exceptions to file, hopefully periodically we will go through this file that has exception and we'll try to fix our program. Okay? So it's indicating that there are some issues that we need to deal with. This is not a built-in function, method. This is some kind of custom method. Think about it as print, let's say system.out.println, something similar. But in practice, we don't just display them to the screen, we write them to a file. Or write them to some kind of database, so we can later on go through this exception and try to improve our program to avoid them. Okay, but that's not the point of this discussion. The point here is that when I have a shared common exception handler, I can, instead of having multiple catch, I can have one catch that can handle multiple types of exception. That's the message here. Okay. Now, try with resources. This is important. Let me explain it through an example. You can see here what I'm doing. I create an instance of this print writer, and then I'll go ahead and try to create an instance of it. Here I declare it, and here I instantiate it. And then I'll start using this out variable to write to the file. Now, as I explained shortly, a good developer should always have a finally block to clean up, which is in this case to close the file. But you know, unfortunately, many developers, either for laziness or don't care, they just don't do this finally block, and they don't close files in many cases. So Java people, they came up with a nice way to kind of force or to kind of auto-close the files or auto-close the resources. So the syntax is called the try with resources. So what you do is in the try, you open brackets, yes, parentheses, you open parentheses, and then you declare and instantiate your variable there. You go ahead and instantiate it here. Inside parentheses following the try block. And then once you do this, you don't have to have a finally block, because this will be now auto-closed. So it's just a syntax improvement where, to avoid this common mistake or common problem with developers not closing resources such as files or database connections or network connections. So here, if we do this syntax, and whenever we use resources that we need to close, we just use try with resources syntax. We do try, we put our parentheses, we put the object that we will be using inside the try block, and we don't need to worry about closing it, because by the time we reach here, the out variable will be auto-closed. So this syntax is exactly the same. Multiple, yes, I think so. We can try. So you can see here, what we have here is I have this is the one syntax of doing it. A better way is to use the try with resources. It's very simple. The try with resources, as I explained, the instantiation will be in the same line as the try. Yes? The instantiation will be in the same line. And then what this will save me, I don't need to close in the finally. I can just simply remove the whole finally. Why we don't need finally block? Because it will auto close. Can we have multiple of these guys? Let's try. Not sure. It looks okay. Yep. I think you can have multiple. And anything you declare in the try will be auto-closed by the time you finish the try block. That's the idea of the try and finally. And this will avoid the common problem of developers not closing resources. Okay. Now this superclass, I already explained it. All right. Already explained it. All right. So now for exception types. In Java, there are so many exception types, but we can categorize them into two types of exceptions. There's something called checked exception and unchecked exception. These are not three types, just two types to keep it simple. Let me explain the difference very shortly. Let me explain the difference. Okay. Now, if you notice here, let me just undo this. Do this quickly. Here it is. Oh. If you notice here, if I try to create this print writer outside here, you see what Java is saying here. Can you see it? Unhandled exception type, file not found. Can I compile this program?
No.
This program cannot compile because basically it has an error. So this exception, which is called file not found exception, we call it a checked exception. What checked exception means? The Java compiler is forcing me to handle it. If I don't handle it, I cannot move forward. So checked exception is an exception that I must handle it. Otherwise, I cannot compile my program. What I mean by I must handle it, I must put it in the try catch. I'm sure you have seen this already. Most of the file methods we have seen so far, all of them throw checked exceptions. What does that mean? You must put it in a try block, otherwise you cannot use them. Because these exceptions are likely to happen. So we try to open a file. In most cases, it will open, but sometimes the file might be corrupted. Somebody might delete it. Maybe you don't have a read access to it. Maybe the file is there, but you cannot read it because of security, like in your lab. Maybe C drive files are there, but you cannot, let's say, read them or change them, yes, or access them. So that is the idea of checked exception. Checked exception must be handled. The other way to do it in the check exception, you can also throw it back. Let me give you an example. Let me just rename this one. Here it is. I rename this one. I will call it write to file. Yes. And here, write to file. Yep. Okay. In here, I insist I don't want to handle the exception for some reason. I insist I'm not going to handle the exception. Yep. So, and this exception, the Java compiler is very stubborn, says either you handle it or I'm not letting you compile this program. Because this exception here is checked exception. But in here I have two choices. Either I must have a try and catch, or I can rethrow the exception. That's the only way. With checked exceptions, I cannot just ignore them. So you see here, it's giving me either two choices. Can you see it? I can either add the throw exception. In here, it says, no problem, I will get a file not found exception. I'm not going to handle it. In this case, what I should do with it? Throw it to the code to worry about it. So, but I cannot ignore it. I have two choices, either to throw it. What's the other choice I have? Handle it by putting it inside the surround with try and catch. Can you see it? I surround it with try and catch. So two choices, either to handle it or to throw it again. Now when I throw it, because I'm throwing it, you can see here, when somebody calls it, you see the Java compiler is not giving up. See here? Says again, the write to file is throwing at you file not found exception. And file not found exception is checked exception. What does that mean? Must be handled or thrown again. Okay? So in this case, if I go ahead and say throw it again, yes. No, sorry, here I'm handling it, or I can throw it. Yep, now it's fine. Now, of course, throwing here means you are throwing it to the Java runtime, which means your program will terminate immediately when this exception happens. So a checked exception is an exception that must be handled or rethrown. Or the method must handle it or throw it. And this is a good example. All IO exceptions are checked exceptions. They must be handled or rethrown again. But if I just here, it might not make a lot of sense. Let me just I'll say throw new illegal argument exception. Illegal argument exception, and in here test. So in here I'm throwing, this method is throwing an illegal argument exception. I can even put it wherever I wish. Here's an illegal argument exception. I'll throw it here. But Java is happy It's not forcing me to handle it. So this illegal argument exception is not checked exception. As developer, I can decide to ignore it completely, no problem. So what I mean here, in Java, there are two major types of exceptions. There are checked exceptions, must be handled, otherwise your program cannot compile. When I say handled, either you put the method call that is throwing at you a checked exception, you must put it either in a try and catch block, or that exception that will be thrown at you, you throw it also, you throw it again to whoever calls you. That's the first type. The other type is called unchecked exception, where it's your choice. Whether you want to handle it, you can do so. If you want to ignore it, you can also do so. When you don't handle it, of course it will cause your program termination. But you can decide not to handle it. So here is the idea. Here is the hierarchy. So the Java has so many exceptions. The roots are this. There is the exception, and there is error. So anything inheriting from error is unchecked exception, which means it's up to you. You can handle it or ignore it. Anything also inheriting from a runtime exception is unchecked. So only the ones that are like highlighted in blue are unchecked. The rest of the exceptions are checked. Is clear? So let me explain it one more time. So all exceptions inherit from exception class. So for example, IO exception inherits from exception class. Class not found exception inherits from exception class. All those exceptions are checked, which means must be handled, cannot be ignored. Except these, anything that inherits from a runtime exception, those are unchecked. This is Java people decision. It's not like that's what they have decided. Anything inheriting from a runtime exception is unchecked. One of them is, you can see here, illegal argument exception. Yes? Like for example, if I throw this, I just give it a try. Class not found exception. Let me try. Class not found exception. You see, unhandled exception of class not found. So this is an exception. Why the compiler is complaining? This one is a checked exception. In this case, I am not handling it, so I must declare it explicitly. In here, I must say that beware, whoever is calling this function can throw at you two exceptions that you must handle. One of them is file not found, and the other one is class not found exception. Class not found exception. You can see here now this one is happy. Now this one, you can see this one is not happy because I have here this class not found exception, and I can decide to handle it. Add, throw, and catch. No, surrounded by try and catch. No problem now. So that is the difference between these two. So just keep it in mind. All exceptions are checked except exceptions that are inheriting from runtime exception and exceptions that are inheriting from error are unchecked. The rest is checked, which means you must handle it.
The program will not terminate if the unchecked exception will happen.
No, it will terminate, of course.
It will terminate.
Yes, it will terminate. In both cases, if an exception happens and you don't handle it, it will cause your program termination. Both of them. What is the difference between checked and unchecked?
You cannot run the checked.
Checked, you must handle. You must. You must put them in try and catch, or you must throw them again to call. But the unchecked, you can ignore them. Of course, both of them, if they happen, they will terminate your program if you don't do anything about them. Okay. Okay. So let me now finalize very quickly. Throw in exceptions. We already seen how to throw an exception. You just put the keyword throw, and then put a new instance of the exception. There are so many exceptions that come with Java. You just make use of them whenever it's suitable. Otherwise, if you want to have your own exception class, you can. And this is how you do it. So if you want to create your own exception class, you create class and you extend exception. So for example, if you have a login screen and the user must type username and password, and if they type the wrong username and or they use the wrong password, of course you can just throw a new exception and give a string saying username and or password is incorrect. That's one way of doing it. But if you want to be very specific, you can create your own exception class. In this case, what did I call this exception class? Invalid login exception. And I extend exception. I must extend exception because to be able to use the try and catch and to be able to throw the exception, I must inherit from the exception class. Yes? And that's it. This class is like a normal class. You can have its own attributes, its own methods. It's a class, basically. You can have your own attributes and methods. There's another example here. Already exists exception. Let's say if you want to add some element to a file, and the file already have what you want to add. You can throw an already exist exception. But this already exist exception does not exist in Java. So you create your own. And in here you can see I added the data to add and destination. Those are extra properties or extra attributes that do not exist in the exception class. So you can add your own attributes and own methods. Once you create a custom class, then you can use it as if it is a normal exception. So in summary, exceptions are a very powerful way to allow us to separate the exception handling from our normal code, regular code. So in regular code, we put it in the try block. The code to handle the unhappy day scenario when things go wrong, I put it in the catch block. The finally block, I use it usually for cleanup. And the alternative to use finally block, I can do the try with resources, if you recall. I do try, and I declare the object that I need to close. I declare them inside the parentheses following the try block, following the try keyword. And this way, these resources will be auto-closed. And I don't even need to have a finally block. So this is basically the idea. Let me, just one second, I will just show you one more. Here is an example of a custom exception. Not found exception. So this not found exception is a class that extends exception, and it takes as a parameter search key. So for example, this is the search key you are looking for. So it's a custom exception. I created myself. It does not exist in Java. And the way I use it, you can see here somebody is looking for this search keyword inside this array. So and this will throw at them not found exception. Not found exception. So what happened is I'll try to look for this search key inside this array. If I find it, I will return the index where that search key happens to appear. Otherwise, if I go through all this loop and I didn't exit with one index, then I'll throw not found exception. This is basically my own class. It takes the message and it takes the search key that's the caller is looking for. And when I run this example here, So you can see here, I'll get an exception. I also get the key that I was looking for. Yeah. So this not found exception, can you see it here? It takes two parameters. It takes a message and it takes the key that the caller is trying to look for. And in here, what I'm doing, I'll do try and catch. And in the catch, I am displaying the message associated with the exception as well as the search key. Yeah. And because this one is inherits from exception, this one inherits from exception, so it is checked exception. I must handle it, otherwise the compiler will not be happy. So if I remove the try, see here I get a problem. Unhandled exception of type not found exception. Why is it checked exception? It inherits from exception. Anything inherits from exception is checked exception, except, what did we say? Except runtime exceptions. Can you see here from this here? Except the runtime exceptions, these are the only ones that are unchecked. So let me see if I can, just to illustrate this one more time. I inherit from this runtime exception. Now, if I inherit from runtime exception, then you see here, my program is happy. Because anything inheriting from runtime exception is unchecked. I don't need to handle it if I wish not to do so. Okay, that's it for the exceptions. So inshallah, next time I will send you an email before that with some ideas about the final exam. The next time, if you have any questions, please prepare them and we will discuss them together. Thank you very much.